Hi, hello friends, welcome back to Max lecture series. In the last class we saw how to calculate the angle between the two vectors directly. If it is given, vector is given, a vector is given, b vector is given, in that case we can directly write down the answer as the value of cos theta can be simply written as a vector dot b vector upon mod a vector dot mod b vector. That's also by substituting like this we can easily express the value of cos theta. From this we can explore the value of theta. But now if you observe the given expression, what it is given here, given it is x y z equal to 1, that is x plus y plus z equal to 1, 2x minus y plus 2z equal to 1. Now the question is find the smaller angle, that is angle between the two planes or dash. Exactly. So how can we calculate the smaller angle between the two planes, sir? Actually, what is the actual meaning of smaller angle is, suppose if the two vectors are being placed like this. So we can measure the angle between these two vectors in this way. We can also measure the angle between these two way. If we measure the angle between these two planes in this way, then the value of the angle is very large. Smaller angle means if you are directly measuring the angle between these two planes here, it will become smaller angle, that's all. Don't think about it too much, sir, what is the smaller angle at all. Okay, anyway, just we have to explore the angle between the two vectors. Same formula, we are not going to use any other things. The formula is whenever you are requested to calculate the angle between the two vectors, again you have to use a vector dot b vector divided by mod a mod b vector only. But in the last case, given it is vector quantity, directly we substituted them and we got the answer. If vector quantity is not given, if a scalar function, see that if you observe, instead of giving the vector quantity, if some other expressions will be given like this, two planes, plane value is directly given like this, how can I express it, sir? In that case, so let me give you same formula only, but we are going to do small modification. Whenever directly plane equations will be given, let me write down the general expression, general way of representation of the plane expression, that will be represented as a1x plus b1y plus c1z equal to, we can consider d1. Similarly, a2x plus b2y plus c2z equal to d2. So this is the plane equation, general representation of a three-dimensional plane equation. From here, if we compare this one with the standard, see, this is the standard one. This is the standard one. We are going to compare the standard one with the given. If we compare the given with the standard one, we can easily explore the value for a1, b1, c1, d1, a2, b2, c2, d2. Anyway, here our attention with the what? Now let me show you how to explore this value. After, just to compare this, if I will compare the equation number 1, let me take this is equation number 1, let me treat this one is equation number 2. Now take equation number 1, compare it with the first equation. Take equation number 2, compare it with the second given. From this I can easily say that the value of a1 equal to, what is the value of a1? Value of a1 equal to 1, value of b1 also equal to 1, value of c1 also equal to 1. So a1 value, b1 value, c1 value all are 1 only. Similarly, if you observe the second one, a2 equal to 2, b2 equal to minus 1, c2 equal to 2. So a2 and c2 both are 2 only, but the value of b2 is equal to minus 1. Okay, sir. So what you have to do? Only two type of expressions. Either they will ask you like the previous one that we saw, otherwise they will give you two type of equation, plane equation directly. They will be asking you to calculate the angle. Sir, how can we do this one? Nothing you need to do. That is very simple. Just take a1, multiply it with a2, a1 dot a2 plus b1 dot b2 plus c1 dot c2. That is what you have to keep it in the numerator, right? And remember, just we have to consider only magnitude of a1 dot a2 plus b1 dot b2. See, let me write it some below somehow, because here the space is not sufficient. Let me write down here. So the expression for cos theta when plane equations will be given, simply written as a1 dot a2 plus b1 dot b2 plus c1 dot c2. In the denominator, take them separately. First plane equation, coefficient of first plane equation squares, a1 square plus b1 square plus c1 square. Similarly, second one it is going to be a2 square plus b2 square plus c2 square. That's all. That is how we are exploring the value of theta. Now it is very easy to observe, and in the numerator just consider only magnitude. Don't consider the sign at all. Okay. So let us see a1, a2. Value of a1 is 1, value of a2 is 2. So 1 into 2 will become 2 plus b1 into b2. b1 value is 1, b2 value is minus 1. So this will become minus 1 plus c1, c2. c1 value is 1, c2 value is 2. 1 into 2 will become 2. Okay, sir. So 2 plus 2, 4. 4 minus 1 will become 3 in the numerator. Let us go to denominator. In the denominator, we know a1, b1, c1 all are 1. So 1 square plus 1 square plus 1 square will become root 3 simply. Keep your attention with the second one also. a2 square, b2 square, c2 square. a2, 2 square, b2 minus 1 whole square, c. 2 square minus 1 whole square will become 1 square, again 2 square. Let us see what will happen. In the numerator already we saw that is 3. Denominator here it is root 3 into, see, 2 square will be 4, 2 square will be 4, 4 plus 4 8, 8 plus 1 9. Square root of 9 will become 3. So 3 will get cancelled out. Yes or no? So finally what we got here, it is 1 by square root of 3. That is the value of cos theta. So this is cos theta. This is not the answer. In order to know the angle, we have to express cos inverse of 1 upon square root of 3. So what will be the correct expected answer? This will going to be 54.73 degree. So that is the correct expected answer for the above given function. So only two way of identifying, either they will be giving you the vector equation directly or they will give you the plane equation. So now you understood in both of the way how to calculate the value of theta. This is all for this lecture. Rest of things you will see in the next class. Thank you all.